Hello everybody, welcome back. Today we're starting Chapter 7, Quadratic Functions and Equations. Some of the ideas is we're going to be able to develop algebraically and graphically how to determine the characteristics of quadratic functions. We're going to be able to use some of these characteristics to sketch the curves, the graphs of these functions. In equations, we're going to solve quadratic equations by graphing, factoring, and by using what's called the quadratic formula. And we're going to solve problems that can be modeled with the quadratic functions and equations. Okay? So these are some of the key words. I'm not going to go through them now, but these are ones I'd like you to read. And these are some of the terminology I'm going to be using within the whole chapter. Okay? Let's look at the first one. We're going to explore quadratic relations, and we're going to learn how to sketch these on the graphing calculator. So I'll get you to open up the graphing calculators, and we'll look at the first graph here, which we can see is linear. And the second one is going to be quadratic, which will be new. But first one we're going to do is graph this linear line that we know how to graph already, but I'm going to show you what it looks like on the graphing calculator. So we're going to open up our graphing calculators. All right. Let me turn them on. And remember to reset. Second function down to plus, which is memory. And we hit 7 to reset. We hit 1 all RAM. And 2 to reset. That'll bring us back to the factory setting. Just hit hit enter, and it'll clear that. So the graph, we go into y equals. I'm going to graph that first one. Remember, the negative is to the left of the enter sign, so it's negative 5x plus 6, or was it minus 6? Sorry, minus 6, easy fix. Now you don't put a negative in here, you actually put subtract sign, negative 6. And we're going to graph this graph. And there's your graph there. Okay? So your graph, it goes through at negative 6, and our slope is negative 5, which means you can go down 5, right 1, which is off the page actually, or you can go up 5, 1, 2, 3, 4, 5, right, or sorry, left 1, which will bring us right down the line. Anyway, that's where we're going to sketch, so I'm going to take a picture of that graph for our page here, and we'll put it in here. There we are. A little too big, but I can fix that. There we are. All right. There's your graph. Okay. So this is called a linear equation. Linear function. All right. Then we know how to graph that before. Now we're going to graph this quadratic 2x squared minus 5x minus 6. So the difference is here we're having a 2x squared, similar to what we had here before. So I'm going to run my graph. We'll graph this as well. Y equals. So it's going to be 2x squared minus 5x minus 6. We'll graph this. And we have a nice little graph here. Okay. And we're going to sketch that. And this is just a sketch. We're going to learn to graph these in much more detail as we move forward. Okay. All right, there we are. And this is called a parabola. So parabola is the shape. And we're going to talk about what this represents as we move forward. What it's called, the shape it takes is called a parabola. And this is the base of our quadratic function. All right. And in standard form, it looks like this. Y equals ax squared plus bx plus c, as you see up here. 2 would be the a, b would be the minus 5 or negative 5, and c would be the minus 6 or the negative 6. Okay? So a moving object is influenced by the force of gravity, and that can be modeled by a quadratic function. So let's take this example here. It says a mini golf hole is on an incline. If the ball misses the hole, it rolls back down the slope. X in time is the time in seconds after the ball leaves the putter. Y is the distance in meters of the ball from its starting point. All right, so remember your windows. Time can't be negative, so you can change your windows on what that looks like. So I'm going to show you what that is in a minute here. All right. Now remember, the distance could be negative because the ball could end up further from the hole, right? So we can look at that as well. So here's what it's going to look like. Remember, if you have a graph here, you can just hit clear and that'll take you to out, or you could hit y equals and take you to the graph. And clear gets rid of the whole thing. And this one was negative 2.5x squared plus 6x. So negative 2.5x squared, I think it was plus 6x. And there's no y-intercept here, so it's 0, so it's going to go through the origin. So we're going to graph this. And now remember, time can't be negative, so we don't need this part of the graph, so we can get rid of it actually. And that's called a window. So you can change the window. So your x max, I usually like to have at least some of the x-axis so you can see it. So I'll delete the 0. I'll leave everything else as is, and then you just get the most of the positive part, right? So sometimes when you sketch your curve, you can do that with your window. Okay? I'll take that graph and we can fill that in here. All right. So sometimes, just like we did in some of the inequality questions, right, you don't need to have negative x. So in this case, x is time. Time can't be negative. So we would just start our graph here and go from there. And I'll show you what that when we're actually sketching these, okay? And again, with the window, you could have just literally made it 0, and then you wouldn't see that at all, right? And it just starts like that. And that's maybe a better example for the time being. But if you want to see the axis, you can. And I'll put that in there for now. Okay. So let's look at how changing some of the variables, some of the coefficients in front of the variables. So we're going to keep A and B the same. We're going to change C. I'm going to do this in a Desmos program. It's really neat when you do it in Desmos. So let's take a look. So in A, we're going to keep A and B the same, so negative 2.5 and 6, but we're going to change the C value. So let's see what happens here with our graph. So I'm going to enter that in. There's a C value, and there's my C value that you see. So as we make it negative, it goes down, right? Because that gives you a y-intercept. And if I make it 0, it goes through with the origin. Sorry. There's 1 and 0. So you can just see how it moves it up and down the y-axis, right? Moves it up and down the y-axis because this is a y-intercept essentially, which is pretty neat. Okay. So I'll put a value in at let's say 5. Let's say 0. And let's say negative 5. And there's the 3 graphs for you. Okay. So I'm going to take a picture of those for our notes. So positive 5, 0, and negative 5 for C. Okay. All right. So what does the change on C affect? Remember, the first graph there is we'll have 5. Second one we put in plus 0, and the next one we put in subtract 5, just to see what it looked like. Okay. And you can see that by changing the C value, the parabola, that's what we call it, right? This quadratic function, the parabola moves up and down the y-axis, right? Okay? Because that C value, all right, let me make a little note here. The C value, so the coefficient there, the constant it's called, the C value represents the y-intercept. All right. So it's really important that we see that. Okay. What happens when we change b? So we're going to keep the rest of the equation the same. We're going to change the b value and see what happens. So the b value is at 6 here, if we make that a 6, but if I change that b value to 0, negative 10, positive 10, what's happening is this is what's called the axis of symmetry, so a vertical line is changing. The axis of symmetry changes, so it's moving to the left and to the right, which is pretty neat. So it's sliding. See, the y-intercept's not staying the same, so the b value is changing, which is causing this to move to the right and to the left. So I grabbed all of the original and I made it plus 10 and minus 10, and I showed you what happened there in the previous part of the video. So I'm going to capture that for our picture. So what you can sketch, and you can sketch these, or like I said, you can follow along. So changing b moves the parabola. The parabola left and right. Okay, so it moves that to the left and to the right. So right here we used a 10, and right here we used a negative 10, right, to show that as we slid it across. Okay, so just be mindful of what we used. Everything else stayed the same. All right, and that is actually called the axis of symmetry, which we're going to learn about. Changes. And the axis of symmetry is a vertical line going through the vertex, and we're going to talk about what the vertex is. The vertex is right at the top of the hill or the bottom, I guess, if you wish. All right, let's look at C. Let's look at what happens when we change the A value. So we have an A value of negative 2.5. What happens is it opens downward now, which is kind of interesting. Or sorry, it continues to open downward. And as we move to the left, it makes it more narrow, the opening, look, making the opening wider, and look what happens when we get to 0. Oh, straight line, because it's not a quadratic, it's a linear line. And then when we make a positive, it actually opens upward. So two things are happening. And we're going to talk about this in a minute. So I'm going to graph 3 of these for you. So here are the 3 graphs, originally with the original negative 2.5x squared plus 6x plus 2. And then we made a negative 5, so it made it a little more narrow. And then we made a positive 5, which made it open upward instead and narrow as well. So it's pretty interesting. So y1 was the original curve here, as we see. When we made a positive 5 for the coefficient, we saw what happened. It made it a little more narrow, and then when we made it negative 5, I should say, it made the negative 2.5 narrow. But when we made a positive 5, it also opened the parabola upward instead. So we have to make note of that, which is pretty interesting. Okay. So what happens when you change the A? 2 things happen. So changing the A value will make the parabola wider or more narrow, and also, if A is negative, it opens downward, and if positive, it opens upward. And if A is 0, as we saw, it makes it a linear line because it's no longer a quadratic. So, some pretty neat things happening in there. All right. So what we're going to do now is we're going to work on some of the questions from page 360, numbers 1 through 6. All right, and that's what we're going to work on now. So thanks everybody for watching. In the next video, we'll start 7 decimal 2.